What are both of the functions written in terms of? Yeah, f and g. They're both written in terms of, well, they're both written in terms of t. I wasn't very clear on that. They're both written in terms of t. So what does that really tell you? It tells you that z is written in terms of f and g, but what are both f and g written in terms of? T. So if you want to find z prime in terms of t, what do you have? Partial z, partial z, partial g, right? Times what? dg, dd. Why is it d? There's only one path, correct? Then you have partial z, partial f times dz, d what? I gotta write this correctly, man. I gotta wake up. df, dt, exactly. So can we figure out both of those things? Terms. So then what's dz df, or partial z with respect to f? What? G of t, exactly. So what's df dt? F prime of t, exactly. So what do you have right here? F of t, g prime of t, plus g of t times f prime of t. What is that? What is this? What? It's the product rule. Yes, exactly. But doing step one, what is partial h with respect to x? Well, you do the derivative of x because x is moving, and then what do you glue onto it? G of y, because y isn't moving. And then if you want partial h with respect to y, you do g prime of y times the thing that isn't moving. Are you with me so far? You with me so far? Yes? Okay. So now xy is equal to f of x, g of y, and what's true? X equals what? T, and y equals t. I'm just summarizing what they're telling us. So if you're going to use that line, and you actually at this point wanted to find what is z prime of t, if you wanted to do what z prime of t would be, that would be partial h with respect to x times dx dt plus partial h with respect to y dy dt. But here's the thing. Look over to the extreme right. What does x equal? T. What does y equal, Umi? So what's dy dt and what's dx dt?
1.
They're both 1, correct?
Yeah.
So what do we now know? We know from this that z prime of t is equal to partial h partial x plus partial h partial y. But what did we figure out up here? We figured them out separately. We did it separately. We did partial h with respect to x and partial h with respect to y separately, like at a different level. So what can we do with those two red boxes now? Where can we bring them down to? We can just substitute, exactly. So we know that z prime of t is equal to f prime x gy plus fx g prime y. My parentheses for some reason are failing today. But what do x and y both equal? T. So what does z prime of t equal? F prime of t, g of t, plus f of t, g prime of t. So you can separate it out and just do it separately. I did a little too much hand waving there. So if you do them separately, you end up with the exact same thing. You just do it at different levels. So this is what I want to introduce today, and what I'm introducing today is really just notation that you need to be comfortable with. It looks horrible, and there's one thing about this that's kind of a tripwire. So second order partial derivatives. What does this mean? Take the partial with respect to x, and then do what again? Take the partial with respect to x. What's this one right here? Partial with respect to y, and then whatever you end up with, do the partial with respect to y again. It gets more fun when you start looking at the mixture. And here's the key thing. Let's look at this real carefully here. What does this mean right here? These three things mean the same thing. They mean the same thing. That's what that cool equal signs mean. Can someone tell me what's one kind of like slight inconsistency that might trip you up? Take a look at just this right here and tell me if you notice anything that's slightly interesting. Here, let's just zoom in on this one right here. So when you're generating a whole list of these, the best thing you can do is first just do, what is fx of xy cade? What's that one going to be? Cade. Yep. 6x e to the y. And what's fy going to be? 2yx. Nice. Plus e to the y. So these are your new functions. So from here, each of these could generate two different ones.